Hello everybody. I'm very happy to be here. It's my first time on the NILM workshop, and I've seen already 5 NILM workshops or conferences in the past have been done. And when I was asked by Bert from NET2GRID to talk something about a product, the iONA product, I have to think about is it a NILM topic, and it is, and maybe it could be very interesting even for you who are very technically interested guys, as I think, to know what NILM can be done for an end customer product. So my name is Peter Schulden. I'm working for innogy SE in Germany. Innogy is one of the big retail and grid companies in Germany. They're actually merging with E.ON. Maybe you have read in the newspapers. The European government has allowed this merger. So E.ON and Innogy are both big companies for energy supply in Germany. Before I'm telling you something about the product, I want to tell you something about the smart meter rollout in Germany, because the smart meter rollout is the basic for the iONA product and gave us a chance to do that. So the German energy market is about 42 million households, so smart meters or meters. There are about 1,000 energy retailers. Innogy and E.ON are only 2 of them. About 900 grid operators who are responsible for the smart meter rollout. And they have to do that until 2032. So takes a long time to roll out all the smart meters in Germany, but it has a reason. They wanted to start in 2016, but they decided to do a very special rollout in Germany, because they have 2 different types of meters. And let me explain what the difference is. And this difference is very important for our product. In Germany, we have 2 different meter types, and only a very small group of customers are getting a real smart meter, what in most countries is a smart meter, a meter with a data connection. In Germany, only 20% of customers will get such a smart meter. It's a so-called intelligent metering system. About 80% of all customers will get a dumb smart meter. It's a simple electronic meter which has no data connection at all. So you have to read the meter as in the past 1 time a year, and the customer gets a bill, and it's the only contact point we as a retailer have with our customers. And the focus of Innogy Retail was a few years ago to make this dumb smart meter even smarter. What have we done? So in the basement of the house, it's a normal case in Germany. The meter operator or the grid operator mounts a new smart meter or a new meter. And the grid company of Innogy, they built a new one, which is equipped with an RF module inside, which is able to send data to a receiving unit. The main reason why they did is they wanted to make it easier, the smart meter reading. Instead of going to the customer's home and reading the meter physically, they wanted to have a chance to get the data out of this meter. So they built a read device. You can see it on the left. This is the grid operator who goes, walks by the house or drives by the houses and gathers all the data from the house. It's done 1 time a year or maybe monthly. We used the same interface and built the iONA box. You can see it in the customer's home. It's a small, very cheap box we developed together with NET2GRID. It's a receiving unit. We are using the LoRa technique to transmit the data from the meter to this receiving box. This box is a simple gateway connected to the Ethernet or to the Wi-Fi of the customer's home and transmits the data to our backend, to the iONA backend. It's done in 1 second data. In the best case, if the transmission is not so good, for example, if the customer is living in the 6th or 10th floor of the house, the connection is not so good, so we have maybe 10-second data or even 15 or 20 seconds data. But in normal case, about 80% or 85% of our customers have a very good connection, so we have 1 or 2 second data as a basic for NILM. So what we did with this solution, we wanted to have a product. The normal customer who gets the dumb smart meter, he doesn't see any difference to before. He had an old meter, a mechanical meter, and it's very boring for him to get a smart meter. There's a big hype for smart meters, but he can't see anything. But it's more expensive for him. Instead of about 10 or 12 euro per year, he now has to pay about 20 euro per year for this new meter, and he doesn't see any difference. There are some new functions in this dumb smart meter. You can store the data for the last 2 years. The user can see this data, but there's no button or any interface on this meter. He has to use a lamp torch to blink signals to this meter to get the information on the display. So it's not usable for the user. With a so-called meter, we have the name meter given by our metering guys who developed the transmitting meter. We can see if we can use this data, we have a big opportunity for our end customers. To build new products, to give transparency over energy demand to the customer, he can see what's going on in my house. He can see the real-time demand and even more if we have NILM. So we built this iONA product. Especially it's an app for the customer. He only sees this app. He has never seen his meter in a regular case because the meter operator just mounted it and didn't tell anything. And in the future, we want to use this NILM data, especially NILM data, for new products. Let me tell what the first iONA product actually is. The user has an app for Android or for Apple phones. Actually has about 7 use cases. They're oriented on electricity. Because we think that the user expects something concerning electricity. We made a big field test before we developed this product. We have a test with about 1,200 real customers. We equipped them with some prototype hardware, so a meter and a receiving unit, and we gathered a lot of information and feedback from these customers. We asked them, what do you expect? What do you want to see? And we have some experiences about challenges and gaming. We have some gaming features in this test app. And the result was the most interesting thing for customers is transparency about energy, about their energy consumption. And things like gamification, maybe they will come later. So this is a set of first use cases we already have. It's the real view of the here on the left. You can have some different levels of details. You can see your demand in the history. And of course, you can see devices, and this is the most interesting feature for our users. We have feedback from them, and they say that's what I want to see. The device tile here, the second from the left, displays how much energy, how much euro did I use on this day or on the last month for different appliances, for washing or for my fridge and for my oven and so on. You can click on each of these levels and you get a detailed view, and the user can inform himself about today, what's the demand of today, how much euros did I use for my appliances, up to a live view on the left, where you can see on second level what was the demand. On the right side, the meter reading, it's still necessary to have the meter reading, because this iONA app is not the official way we can, which we can use to produce our bills. We still have to wait for a meter reading from the grid company to build our bills, because this data path we are using here is not the official path for billing. It has to be done from the grid company to the retailer. Maybe in the future we will change that, or we are allowed to change that, but actually we have here the meter reading for the customer. He can check his bill, entering some date in the past, and can see what was a meter reading on this day. Up on the right side, the rate check, very interesting for our customers. They are paying a monthly fee, and with this rate check they can see is my monthly rate, is it too high or too low. It's a bill prediction to the end of the year. When the customer gets a bill, and he can see in the app, will my bill be higher or lower than I expect. And then you can change this monthly rate and adapt this rate to his predicted bill. So this list of use cases is getting longer. We are thinking about new use cases, but even for this list of use cases we have a very good rating in the app stores, very good feedback. So the customer loves this kind of transparency he gets, because he didn't know everything about energy demand in the past. He only get one bill in the year, was shocked or was happy, I don't know. But now he has a real view, what did I use the energy for? And yeah, you can read the feedbacks in the App Store, so it's quite successful. So we are thinking about new products. Actually, this app is an informational product for our customer. It's free of charge. They can use it if they get this new meter. But we are thinking about new products. For example, NVRM is one of the companies belonging to the innogy group. They are selling a product with an happy hour component. Happy hour means the customer has 1 hour per day free. Actually, it is fixed from 18 to 19 o'clock in the evening. And in this hour, he gets the energy for half price. And on a monthly basis, he gets this kind of report you are seeing here. So he gets a report about his different appliances, what have I used in this last month for any appliance, and of course the happy hour reporting, how much euro and kilowatt hours did I use within the happy hours in the last month, and how money did I save. He gets a payback at the end of the year, so it's quite simple to bill that. He gets a bill of the whole demand and gets a payback for the happy hour. This is a quite simple product, but it's very successful at our customers, because they directly have an influence on their energy bill. Another product, maybe you know that innogy is one of the one supplier of smart home products in Germany, one of the market leaders in this market. And we have developed a piece of hardware. It's called Power Checker. It's a smart plug, but it has the same functionality as this iONA box has, as you have seen in the slides before. So it contains a gateway to the MEDA meter, to the iONA meter, and a smart plug functionality. And we will use this piece of hardware to migrate iONA customers to smart home. You can there is a simple switch function within the iONA app, so you can switch on and switch off this plug. And if you want to do more, like time-based switching or combine it with other smart home devices, you can use the smart home environment and smart home other smart home device to do that. Okay. That's it. Do you have questions?
Hello, my name is Johannes Schnitzler from Innogy, and my question is, you mentioned that you have a different granularity on the data from 1 second to 10 seconds, depending on the living conditions of the customer.
Yeah.
And what is the accuracy that you receive in detecting certain devices through NILM algorithms?
Okay, maybe we should wait to answer this question for Bert, because he will tell you something about the NILM algorithms we are using in iONA, because the NET2GRID has developed these, and I think he can answer this question best. Yeah.
Fair enough.
Please.
Hi, I'm Surush from Onzo. So you have a feature on your app called Consumption Alarm, I think.
Yeah.
What is it? Could you give us some overview of
It's a very simple function. So the customer can define a level of watts, and if it's reached, then he can get a simple message. Yeah. Yeah. So many customers, for example, if they are in holidays, they want to set this level and say, I want to know if something is going on in my home, and they get a push message.
Just because what is the standard of communication between this meter placed in basement and customers on the, let's say, fifth floor? Is it open standard or your company?
It's a company standard. The company Lemonbeat is part of the Innogy group, and they've developed the Lemonbeat stack, and it's a transmission mode and security and so on. We are using between the meter and the gateway.
If talk about radio frequencies, is it sub-gigahertz or?
Yes, it's sub-gigahertz, 868 megahertz, so it's an ISM band. Yeah.
Ollie Martin from Hive. You mentioned that there are 2 routes that data can arrive in your backend. So either through the official route, used for billing, and also through, I guess, the iONA routes as well. I'm wondering if there are any circumstances where these 2 routes ever disagree, and what the causes of that might be, but also how you handle that as well, because I guess that can be quite confusing for the customer.
Okay, you mean the two different meter types? Yeah, actually, we only transmit the data from the 80%, so from the MEDA meters. The other group, they transmit only 15 minutes data. It's more grid-oriented to control the grid. It's not end-user oriented. Yeah. Other questions?
So I have one question. Suke Schüters from Germany. How does this communication unit talk to the dumb smart meter? Is it via this optical interface?
No. Let me go back to the slide. Well, let's take this one. So actually 3 meter manufacturers are building the meter. They install the RF module directly into the meter. So we are internally using this optical connection. So the same data as on the optical interface is coming out, we are using for this transmission module. But it's built into the meter, it's completely sealed, and it's an official certified smart meter.
Thank you.
Okay. Last question. No.
Should we jump into part 2? There'll be more questions at the
Yeah,
end.
sure.
Okay.
Yeah.
So thank you, Peter. Great presentation. My name is Bert Lutje-Berenbroek, CEO of NET2GRID. And last year I had a short pitch and I spoke a little bit about business cases and real commercial deployments of NILM. And the organizing team of the NILM conference asked me to organize a keynote speech together with Innogy to talk about what are the requirements and what are the conditions that you need to meet in order to roll out a NILM service in high volume in the country. And this is what we try to capture in this combination keynote speech. So Peter spoke about what are the company benefits and the marketing conditions you need to meet and the customer expectations on a service. And I'm going to talk a little bit about the technology behind. So in the iONA service, we're providing the hardware, so the gateway that is communicating with the meter, the cloud platform capturing all the data, and providing the APIs to build the use cases in the app. We're not building the app. There's a third-party company that has designed together with Innogy the customer journey and the presentment of data. But we do provide the NILM service, so the analytics of the data. So what are the requirements? The first requirement that we discussed with Innogy is that an energy insight service is still a very low interest product for consumers. Consumers are not willing to interact a lot with a service, and they're not willing to spend a lot of time to configure and train a service. So the service should be without any configuration. It should work without any user interaction. The service should provide daily appliance events, and the appliance events should be accurate in defining when appliances start, when they stop, and how much energy they consume. And that the level of accuracy should be at 90%. If you're below 90%, then customers start to call support, they have questions, and they start to distrust a service. So you should be meeting the 90% level. And the aim is to give consumers insight in their energy bill. And in order to do so, you need to capture about 80% of the monthly energy usage of a consumer. So the coverage should also be above 80%. Now, in Germany, we had a couple of specific requirements that were caused by the actual meter installation, by the infrastructure that is used in Germany. So due to the RF connection with the meter, and the LoRa standard that is used, you can be confronted with varying granularity. So the granularity can go from 1 second to sometimes 20 seconds, and you need to deal with that. In Germany, all meters are 3-phase, but depending on the wireless condition, sometimes we only have enough throughput to get the total phase. So we need to deal with data coming from meters that are both 3-phase and sometimes single-phase. The other requirement in order to deliver the service at the budget, at the cost budget within an acquisition and a retention program, the hardware cannot be more expensive than roughly 20 euros. And the NILM service, the operational service, should not cost more than 5 euros per customer per year in volume. So those were the basic conditions we had to work with and deliver the service. In order to achieve that, we are limited in what we can do in hardware. We are using hardware based on a Wi-Fi SoC in order to meet the cost point. And the data we capture is not high frequent data, it is standard HAN-based, so home area network-based smart meter data, 1 to 10 seconds. And the NILM service that we run is run in the cloud. So besides the license fees and the hardware fees, there's also the operational cost of running a NILM service in the cloud, which should be very low. In order to reach these requirements, we have models, we have built models with a reduced set of parameters in order to run them very efficiently every night. So our service is based on a training period where we are building models during a training period, and after the training is done, we run the models every night and we disaggregate the data of the last 24 hours. The training period is split in 2 parts. We very quickly build models that are not time-based. For example, the always-on consumption, lighting, entertainment, the fridge. These consumptions don't have a start and a stop time. They're calculated on a daily basis. And then there's a whole set of appliances that where we build models for that have a very specific start and stop time based on the operation of the appliance. And that second set of appliances require a bit more time, 30 days, in order to build the models. And sometimes appliances are being used only in the summer, some appliances are only being used in the winter, so you have seasonal influence. And you need to be able to have your training process operating in a recursive way. The data that we capture from smart meters is coming in Germany from a LoRa connection, but in other countries data is coming from a physical port on the meters, sometimes via Zigbee Smart Energy, sometimes via an optical interface. So there are numerous ways we capture data from smart meters, and we are building a service where the actual service that we build is not depending on the meter infrastructure. So we are agnostic for the meter infrastructure. And that's why we first harmonize every data set that we collect to the Zigbee cluster library standards in order to be able to build services on top of data in a standardized way. So there's kind of an abstraction layer that is meter and country specific. And on top of the abstraction layer, the service is the same in every country. In that service, we support both 1 and 20-second data models, and we support total and 3-phase models. So we build models if an appliance is detected on a specific phase. We build a model on a phase, and we can tell customers which appliances are active on which phase. And sometimes we have models for appliances that are actually using all 3 phases in common. So even though we are using three-phase data, we still have appliance models that are using all three phases. You have to think of electric vehicles, heat pumps, some ovens are using multiple phases. There is support for active power only, because most meters that we interface to only give us active power data. In the Netherlands, the new generation meters, we're experimenting with also reactive power. And in Portugal, the meters are providing actually both active and reactive power. And we're building models that are using both data streams, because some appliances are very, very difficult to disaggregate, and Dimitris will tell you tomorrow more about specific challenges we see in building models. But in order to achieve our accuracy, we are using both the data stream from the active and the reactive power in order to build models, complex models with more accuracy. Then Peter already mentioned in his presentation that one of the commercial use cases for NILM is not just advising customers to use energy in a different way, or advising customers how where the energy bill is going to. One of the use cases is also the upsell to smart home. And for smart home, there are a lot of use cases that are not directly energy consumption related, but that are very interesting to provide and which you can actually build based on NILM services. So one of the use cases we've built is our models that are running on the hardware. So remember, the equipment that we have to run on is still very cost effective, so around 20 euros. But we're running models, very lightweight models that are built in the cloud, and where the parameters that we create in the cloud are sent back to the hardware, so we can actually run them in real time. And those models can detect, for example, when your washing machine is finished, and send a push message to the consumer, informing the consumer like, hey, your washing machine is finished, and you can now unload it and load another wash. In order to do that, you need to have the infrastructure to have an always-on bidirectional communication with the hardware, which we have. You need to have an infrastructure where you build models not using high-frequent data, but just the data available from smart meters. The hardware that we provide, we have built on a Wi-Fi SoC. We have harmonized the same infrastructure on all our hardware SKUs. So we're basically building hardware, and we develop hardware as if we were developing software. So all the SKUs are using the same code base with small adaptations. The Wi-Fi SoC is using both Wi-Fi and Bluetooth. I'll tell you later why Bluetooth is so important in our business case. And we're running on a very simple RTOS with limited program and data memory. The different SKUs that we support are the standard gateway. The iONA box is an example of a standard gateway. We support Ethernet, Wi-Fi, Bluetooth as standards, and we have LoRa, Zigbee, and other wireless interfaces on the gateway. We have a plug. The iONA Power Checker is an example of the plug. It's a 3-radio plug, Bluetooth, Wi-Fi, and LoRa. We have a version with Bluetooth, Wi-Fi, and Zigbee as well. We have a touchscreen TFT thermostat, which is supporting again LoRa and it's supporting again Wi-Fi and Bluetooth and Zigbee to connect to the smart meters, Zigbee Smart Energy. We have a dongle, which is our lowest cost product for the Dutch market, the Portuguese market, the Scandinavian market. It's a product that in volume can be shipped at around 10 euros. And we have, for markets without any smart meters, we have built a DIN module that can be placed in the metering cabinet. And obviously this is not a self-install product, even though most of you here in the room could actually install it themselves. For consumers, it's not a self-install product, but it's very easy to install. You just click the clamp around the mains stream. We have a single phase and a three-phase version, and the voltage we measure through the power supply, which are just a line and a neutral connection. So it's a very easy to install product, but it does give us much more richness in data. Since you're in the metering cabinet, you're always within Wi-Fi range. Installation again, very easy via Bluetooth, and we're measuring voltage, we're measuring current, we're measuring real power, active power, reactive power, and we can oversample and get much more granularity than just the 1 second data out of the product. I mentioned a couple of times during the presentation that Bluetooth is so important to us. One important part in reducing the operational cost is actually the support. We are really keen on making the product plug and play. It should be as simple as installing your Chromecast. And we have standardized on onboarding hardware via Bluetooth. So the consumer can simply detect the device via a smartphone and configure Wi-Fi via the Bluetooth interface to the device. If you use other mechanisms like connecting to a Wi-Fi access point to configure a piece of hardware, definitely on iOS you always have to move away from the app and go to your configuration settings. And we have seen in the field that this is too complex for the large customer base that we're trying to serve with the product. And making sure the product is plug and play and that the installation is easy is a key requirement for a large-scale rollout. And I believe, when I remember the customer feedback, Peter, that the appreciation of the hardware onboarding on iONA was between 80 and 90%. Yeah. The onboarding is 100% secure, encrypted, and it's a proven concept. It's the same onboarding Google uses for all their devices. As I mentioned, we have meter-agnostic hardware. So in Germany, we use the LoRa interface. We have, for every meter, we have an interface, either wired, wireless, optical, or via a clamp. And we have, for all the SKUs, we have a product which is Wi-Fi based for the use cases where the meter is within Wi-Fi range, and a LoRa-based solution for meters that are outside Wi-Fi range. Like in Germany, the meters are in the basement, you have multi-family homes, and there's definitely not always a Wi-Fi connection in the basement, so we have a LoRa connection to the meter. Same in France, there the meters are on the fronts on the street side of the garden, and there are many different countries where the meters are not within Wi-Fi range. So we've standardized on having a LoRa connection to the meter. The challenge to provide NILM on LoRa is that depending on the wireless conditions and depending on the distance between the meter and the home, you will get different granularity. As Peter mentioned in his pitch, the results are pretty good. We get out of the installations we have more than 95% of the meters on FSK. So we have a very high percentage using 1 second 3-phase data. But if FSK doesn't work because the distance is too large or the wireless conditions do not support it, thick walls, iron doors, you name it, then we are using a LoRa spreading factor where we basically compromise the data throughput for range, and we have less data to work with. And if you have less data to work with, you might, if the conditions are more poor, you might not be able to capture 3-phase data anymore, and you only have 1-phase data, the total phase data. So you need to have a NILM infrastructure that can work with, that can build models that can work with data that is either presenting the total consumption of the home, or data that is actually coming from a specific phase. And you need to have models that work with like high granular data and low granular data. So that was definitely a challenge. We have optimized the solution that we are deploying in the market over the last 2 years. We have achieved to meet the requirements of capturing or mapping more than 80% of your consumption into appliance models, and to achieve a 90% accuracy. Dimitris, in his presentation tomorrow, will tell you more about how we are using ground truth and how we are building a large data set in order to train models and to measure the accuracy. But basically, if you look at the releases, we are running every quarter. So every quarter we deploy a new version of our NILM service to all our customers. We have added both new appliance models. So we're training new appliances, and we're updating appliances based on insights, operational modes that we get, new appliances that appear in our customer base. So over time, our solution is improving. And if you look at the improvement we've seen since we have started with the pilot in Germany. We started with a coverage of about 45% and an accuracy of roughly 80%. And by optimizing the service and optimizing the models on a monthly basis, and we have a 3 months rollout of new versions, we slowly optimized the accuracy and captured more appliances and captured more models or usage models for the same appliance, where we are now above 90%, and we're above 80% of the mapping of the total household energy. That was my presentation. Any questions?